And then God said, "Let there be light." The creation of light and the separation of light from darkness was God's first act of creation. So light is very important. Scriptures also say that God is light. Light is a very important analogy for us to understand God. You might think one of the reasons why we can't see God is because if God is light, um, it kind of makes it hard to see him, just like it's hard to see me right now because the light coming from me is interfering with your ability to see me. If I take this light off and point it at me or at the side, now you are seeing the light reflected off me into your lens. This is a very important property of light. When it's shining directly at you, it's actually harder to see. Light is always better when it's at the side or in behind. In photography, we say that's backlighting in some cases. Or when we try to take a picture, we don't want the camera pointed directly into the sunlight. Of course, we don't want people staring directly into the light either, because then they're squinting. Actors and people who work in theater have to get used to staring at the lights. So while the lighting on the stage is good for the audience to be able to see the actors and actresses on the stage, the actors and actresses don't actually see the audience because the light is pointed directly at them for the benefit of the audience. There are other ways in which light is an excellent analogy for God. Light is timeless. It never gets older. It's ageless, just like God is ever old and ever new. Light also travels very fast, but not just that. Light travels at a constant fast speed, and it turns out that all other speeds, all other moving objects are relative to it. So it doesn't matter how fast something else is going, it's always a fraction of the speed of light, that constant light, just like God is constant, ever ageless, ever new. You are the light of the world. A city built on a hill cannot be hid. No one, after lighting a lamp, puts it under the bushel basket, but on the lampstand, and it gives light to all the house. In the same way, let your light shine before others, so that they may see your good works and give glory to your Father in heaven. By doing good deeds, we are letting our little lights shine, or we are allowing the source of all light to shine through us. But what might seem even more interesting is that we ourselves do actually give off some light. We give off some light that you normally can't see. Most of us understand that we give off some heat. We're always a little bit warm, and if we have a fever, then we're giving off even more heat. But if we're giving off heat, we're also giving off light. A light bulb gives off both heat and light. Our bodies give off heat, and we also give off light, but not a light that you can see. It's light called infrared light. Now, red light is a light that you can see, so infrared light is a light that's just outside of what you can see. But is it? There are some throughout history who have been able to glow. They've actually given off more light, a light that you can actually see. This is where we have the idea of a halo. The halo isn't just a decoration to adorn holy people in paintings. The spiritual light of the saints is also a real physical glow, not just an invisible red, but a combination of all the visible light. The more that you let the light of God shine through you, the more you glow.
One of the apostles is not like the other ones.
Those who have made pilgrimage to the shrine of Our Lady of Guadalupe in Mexico City have noted the exquisite beauty of the image on the tilma and attest that no reproduction, no painting or sculpture comes anywhere close to the original image. This is not just mere sentiment, as close study of the original image on the tilma has revealed that the image is not a painting at all. The image sits, in fact, miraculously on top of the tilma, and it is an image of light. No wonder it can't be reproduced with painting if you're competing with the light of God itself passing through the image. And this is very relevant considering that we see Mary as transparent, as having nothing that impedes the grace of God flowing through her. And so an image that's of Mary that's made up of light is a perfect way to describe her.
Of all the depictions of Our Lady of Guadalupe, I suppose stained glass would be the best, because light is passing through the image.
If you've ever seen a computer connected to a light projector, you've probably seen it hooked up with one of these. This is called an RBG cable, which stands for red, green, and blue. Now, how would red, green, and blue take all of the colors that are on your computer screen and put them onto a light projector? Well, it turns out that the three primary colors of light are red, green, and blue. And when you mix those colors in various proportions, you can generate all of the colors, including white. Now, we're going to set up this experiment, but it's going to take a little bit of time. The first thing you need is to generate some filters. I've got a flashlight here, which emits white light, but I'm putting a green cap on it so that the light comes out green. If it comes out green, it means all the other colors have been filtered out by this green cap and only green is remaining. I also need a blue light. So I've got another flashlight with a blue cover on it so that it will only emit blue light and all the other colors have been filtered out. Lastly, I have a third flashlight that has a red cover on it, and the red cover filters out all of the other light, but leaving behind just the red light.
Filters for your light experiment, you want to try and find dark red, dark blue, and dark green. But you also have to try and balance the thickness of the filter with the strength of the light so that they're relatively even. So if you have a stronger light, you want to cover it with a thicker filter. And likewise, if you have a light that is less strong, you want to pair it up with a filter that is thinner.
In order to see the effects of mixing the three primary colors of light, you first of all need three hands, or in my case, I'm going to suspend my green light and then use my two hands for red and blue. You also need a really dark room. You have to do this at night with the lights off so that there is no other interfering light in the background. Green and red are two primary colors. Now, when green and red mix, you can start to see a little bit of yellow. Green light and red light makes yellow. We also have blue light over here. Blue light and green light mix to form a lighter blue that we call cyan. You might think of it more like sky blue. It's a lighter version of blue. And red light and blue light mix to form what's called magenta. It's a light purple. if you will, a pinkish purple. Now, when we bring all three of these lights together, we should see a general brightening as the three primary colors of light come together to form white light. Now, depending on the relative strength of these lights, we may not get a full whitening, but you can see apart their three colors. And then when we bring them together, we start to get something that is much brighter, approaching white light. And in between, you can see the three secondary colors, the magenta on the bottom. You can see some of the yellow on the upper left, and you can see some of the cyan on the upper right. And while it's difficult to see the individual colors, as when all three lights are together, you can definitely see the difference when the three lights are apart. The basic primary red, green, and blue coming in to form lighter colors, and then all together forming a white light.
In order to achieve that perfect white light, all three primary colors must be perfectly balanced in strength, which is difficult to do in an at-home experiment.
While God paints the black formless void with a spectrum of different colors of light, we usually do the opposite. We usually start off with a blank white canvas and then add colors to it, but we're not adding light, we're adding actual stuff, paints, pencil crayons. We're not adding light, we're actually subtracting light. And if you know from Mrs. Sweeney's class, if you add more colors together, you don't end up with something that's brighter, you actually end up with something that's darker. If you've ever had to change the ink on your printer, you would know that there are two cartridges. There's one for black, which is used most often, but a color printer has a color ink cartridge, but it has not red, green, and blue. It has the secondary colors of light, the magenta, the cyan, and the yellow. Those three colors are the primary pigment colors, and that's what we use to mix it up on our white canvases. These three primary pigments of yellow, cyan, and magenta will help us to make all colors, even black when they're combined. But we're not going to use up colored ink to make something black. That's why we have a separate black cartridge for things that are only black. Adding pigments is what we call the subtractive theory of color. If we have cyan, yellow, and magenta pigments, we know that each of those colors represents the addition of light, but when we have them in pigments, they actually end up subtracting color until you get black. For cyan and magenta, they mix to form a much darker blue. Magenta and yellow come together to form a much darker red. Yellow and cyan come together to form a darker green. And if you mix all three of them together, the magenta, the cyan, and the yellow, you will get black.
Cyan filters out red, yellow filters out blue, and magenta filters out green. So once you combine magenta, yellow, and cyan, you've filtered out all three of the primary colors of light. And if blue, green, and red have all been filtered out, there's nothing left but black.
I hope you've enjoyed the last 6 weeks of science grade 3 and 4, and that you'll find creative ways to let your little lights shine.